This video is with regards to assignment C number 25, and it's a Z-test for mean. Here you can see that the Google Meet we were using is PRK-T and II-TMB. And this here following is an example of number 25 in assignment C. So here's number 25 in assignment C. It says that John claims that the maximum score that Math 1-to-1 students can achieve is 75%. You are given the task of testing the above claim by first completing the topic, research question, hypothesis in symbolic form, and the objective. The hypothesis must be in symbolic form because for Z-test forming, you must translate the hypothesis to symbolic form. So here's an example very similar to number 25. The claim here is the population mean mu is 86%. So that's the claim here. So we need to translate this worded hypothesis to symbolic form. Now, apart from the weekly news number 9, we will be using the supporting document named Research Project and Hypothesis Testing. Here you can see an elaborate series of steps to perform hypothesis testing using the critical value approach. And we are specifying on the Z-test for mean. So as you can see, the first step is to translate the stated hypothesis in mathematical or symbolic form, and then to identify whether it is a null or an alternative. Now, we know for sure that the null always carries the equal sign, less than or equal to, more than or equal to, or the equal, and the alternative does not carry the equal sign. So when the translation was done from is to the equal sign, you can clearly see that this will be a null statement. Then this is followed now by the completion of the pair of hypotheses, the null and the alternative. So due to the fact that our null was is equal to, the alternative will be contrary, it will be not equal. So this will be the pair for the HO and the HE. The HO, the null will be saying equal, while the HA will be saying not equal. And here you can see it completed here. The mean is equal to 86, and the mean is not equal to 86. And we consider this like two persons debating. One person is called the null, and the other person is called the alternative. So now when two persons are debating, you need a rule, and you need a third person now to decide who wins the debate. The rule here will be the distribution curve with the rejection region on it. Okay, and as you can see, this will be the following step. Step number 4, to sketch the distribution curve. It will be a bell-shaped curve, and the critical region will be on both sides of the curve because the critical region depends on the sign of the alternative statement. Here it is written. The critical region follows a sign of the alternative statement, and because the alternative statement here, the alternative hypothesis is a two-tail, so we've got two rejection regions, as you can see stated here, and two critical points on the left side of 0 and the right side of 0. Left side is negative, right side is positive. Then we've got to plot the critical value on the critical point. And the critical value here for this example is negative 2.33. So we put negative 2.33 on the left side and positive 2.33 on the right side. So we have just created the rule that the test statistic can use, which will serve as the third person or the referee or the judge to decide if it's to reject or not to reject the null. That's the rule. So the Z-test statistic can either tell us to do one out of two things, either to reject the null, that is if the test statistics comes in the rejection region, or not to reject the null if the test statistic is not in the rejection region. So after we have set up the rule, which is the curve with the rejection regions and the not rejection region, we need to calculate the test statistic. as is stated in step number 7. Here's the formula to calculate the z-test statistic, because this is a z-test for mean, a standardized test. The information to substitute into the formula for the z-test for mean, for the calculation of the test statistic will be provided, which is the sample mean. Here we have 88. The population mean mu is already in the pair of hypotheses. The population standard deviation, here it is 10.5, and the sample size, which is 36. And as you can see, these values are substituted into the formula. 88 minus 86 is 2. Square root of 36 is 6. 10.5 divided by 6 is 1.75. 2 divided by 1.75 is 1.14. So now we have called up, we have calculated the z-test statistic, which will serve as the referee, the judge, if you want to put it that way. So now we move on to step number 8. We need to plot the test statistic on the distribution curve. In that way, we will know what to do. It will tell us what to do, if it's to reject the null or not. So because 1.14 is less than 2.33 and it's a positive number, clearly you can see that it is not in the rejection region. So clearly the test statistic is telling us do not reject the null. So that's what we have to decide for step number 9. As you can see, it is written, decision time. Reject the null if the test statistic is located in the critical region. Do not reject the null if the test statistic is not in the critical region or the unshaded region. So therefore now, since our test statistic is not in the critical region, the decision is not to nullify or not to reject the null, symbolized HO. In conclusion, it reads, if the null is rejected, remember these are two persons debating, and the null is waiting to hear what is going to happen to it. Okay, so if the test statistics say reject the null, then the alternative will have to celebrate and say, well, I have won the debate. So the alternative will be the conclusion. But if the null was not rejected, so therefore now it will have to celebrate and it will be the conclusion. So in this example, the null was not rejected. So based on the data, the population mean is equal to 86. So this is the values for the example. And here is assignment C number 25 values according to a student. So the test statistic, they got it to be 3.95. And the critical values was minus 1.96 and 1.96 positive. 3.95 is more than 1.96. So they opted to reject HO logically because the test statistic is telling them to reject HO because it is in critical region. And they have to conclude with the alternative because they have rejected HO. So that's what they say. So their conclusion is based on the data. The mean is not equal to 75. 75 because this is the population mean that was in the claim for the assignment C number 25. So here you have an example of a z-test for mean, two-tailed test.